Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. And we meet again here, and in this video we're going to look into continue our discussion on topic of differentiation. And today we're going to look into the differentiation of exponential, logarithmic, and trigonometric function. So then let's take a look at this one here. So at the end of lesson, students are able to derivative of the function of exponential, log, and trigo. So we can look into these three parts and solve problem involving a combination of differentiation rules. Okay, for the exponential function, the Euler's constant of e with this special character of exponent, okay, e to the power of x, then differentiate this even 1,000, 100 or 1,000 times, it can give you, we call the function of e to the power of x. Okay, please to remember this. And differentiate of e to the power of fx with respect to the x equal to, okay, differentiate fx, come up with the f prime here, and then e to the power of fx. Okay, so the derivative of e to the power of fx, okay, where u equal to fx. So then differentiate of y respect to the u equal to e to the power of u, and du dx equal to f prime x. So then du dx equal to, okay, this as a look, if you see here now, e to the power of u, e to the power of fx. So here, then here, and f prime here. Thus differentiate e to the power of fx respect to the x equal to f prime x e to the power of x. Okay, now let's take a look at this one here now. For e to the power of x equal to, okay, differentiate 4. So differentiate 4 times e to the power of x equal to 4e to the power of x. Now, the next one here, fx equal to e to the power of 3x. Okay, so it means that this is considered as an e to the power of fx, and then f prime x equal to f prime x e to the power of fx. So in this case, it's come out with 3e to the power of 3x. Okay, then next, this one here, it is differentiate x squared equal to 2x and then e to the power of x squared. Okay, and then this one here now, it is equal to e to the power of x to the power of half. Okay, so in this case, we are going to differentiate this first. Differentiate x to the power of half, which is 1 over 2 x, and then half minus 1 equal to negative 1 over 2, then e to the power of x to the power of 1 over 2. So this is u and this is u prime for fx and f prime. So 1 over differentiate half, 1 over 2x power of negative 1 over 2, then this gives you what we call e to the power of square root of x divided by 2 square root of x. Okay, so this one here equal to 2 to the power of 1 over 2 square times square root of x, and e power of square root of x is something else here. Okay, so right now differentiate respect to the x. Okay, so let's take a look at this one here now. This is in the form of e to the power of fx. So differentiate this function respect to the x equal to f prime x. So f prime of this y prime or dy dx, okay, y prime or dy dx equal to, differentiate this first, 2 times negative 3 equal to negative 6x, okay. 2 times negative 3 equal to negative 6x, 2 minus 1 equal to 1, plus 4, then e to the power of negative 3x squared plus 4x. Okay, and so let's take a look again here. E to the power of fx, differentiate this equal to f prime x. So differentiate this first. Okay, 2 times negative 3 equal to negative 6x, 2 minus 1 equal to 1, then differentiate 4x equal to 4, multiply with e power of fx. Okay, now just imagine that this is u and this is v. So u equal to an x, then u prime equal to u prime equal to 1, and v equal to e to the power of 4x. So then v prime equal to, differentiate this, differentiate 4x equal to, then come up with 4 e to the power of 4x. So now differentiate y respect to the x equal to, okay. So let's take a look at this one. You know, u v prime plus v u prime. U v prime, u equal to an x, and v prime equal to 4e to the power of 4x plus with v u prime. V equal to e to the power of 4x and u prime equal to 1. Okay, so simplify all this in here. 4x e to the power of 4x plus e to the power of 4x, and since we have this, we call e power of 4x for both terms here, of 4x, e power of 4x plus and e power of 4x. So there we factorize this e to the power of 4x, okay, multiply with 4x plus 1. Okay. Okay, now we are going to use this, and this is our reference here now. Let u equal to 3x plus 2, then u prime equal to 3, v equal to e to the power of x, and v prime equal to e to the power of x. So f prime x equal to, okay, for this one here, u prime v, u prime multiplied with v. So u prime equal to 3 and v equal to e to the power of x minus u, 3x plus 2, and v prime equal to e to the power of x divided by e to the power of x squared. Okay. Look at this one here now. E to the power of x, e to the power of x, and e to the power of x squared is just like we may cancel this and this, and with one of the e to the power of x. So now we got 3 minus negative times 3x minus 3x negative times 2 minus 2 divided by ex. Okay, so 3 minus 2 equal to 1 minus 3x divided by e to the power of x. Okay, Now let's take a look at the next. Derivative of exponential function for a greater than 0 and a cannot be equal to 1. Okay, for this case, we just assume that, okay, we take example of 2 to the power of x, 5 to the power of x, 7 to the power of x, and you just name it. Okay, as long as the function we call begin with the a here, where a cannot be equal to 1 and a is greater than 0, so a equal to 2, 5, 4, 6, 7, and so on. So the differentiate a to the power of x respect to the x equal to a power of x multiplied with natural log of a. And derivative of a to the power of fx respect to the x equal to f prime x multiplied with a power of fx multiplied with natural log of a. Okay, so now, what about this one here now? Y 5 to the power of x, so then y prime equal to 5 to the power of x natural log of 5. Okay. And for this one here now, what about this? Differentiate, we call a to the power of fx. So let's take a look at this one here now. For we call example of b, we refer to this one here now, f prime x multiplied with a to the power of fx natural log of a. So then here now, differentiate this x squared minus 2x. Differentiate x squared 2x minus differentiate 2x, come out with 2. Then multiply with, okay, 3 to the power of x squared minus 2x multiplied with natural log of 3. Okay, so you can see here now, this is equal f prime x, then 3 power of fx multiplied with natural log of 3. Okay, so you may try this, okay, as an as an exercise. So good luck to all of you to try all this exercise of a, b, and c. Okay, now derivative of log function. Natural log of x, differentiate natural log of x equal to 1 over x for x greater than 0. And natural log, differentiate ln of fx respect to the x equal to f prime x divided by fx for fx greater than 0. Okay, now look at this one here now. Okay, first differentiate y equal to natural log of 3x, so then y prime equal to derivative of differentiate ln, it gives you 1 over 3x. Okay, and then differentiate 3x, it gives you 3. Okay, let's take a look again. Differentiate, we call derivative of ln fx respect to the x equal to f prime x divided by fx. Okay, so it's just like derivative of ln equal to 1 over fx, then differentiate of fx. Derivative of fx respect to the x, then it gives you f prime x. Okay, so then here now, then they give you 3 divided by 3, it is 1 over x. Okay, next. Okay, so what about this one here now? fx equal to natural log of 4x plus 1 to the power of half. So using log's rule, log a to the power of b equal to b log a. So bring this b to the front here, can equal to half natural log of 4x plus 1. Okay, let's begin now. Where f prime x equal to, so these are just a constant 1 over 2. So we write it all again. Then differentiate ln 4x plus 1. So differentiate ln, it gives you 1 over 4x plus 1. And don't forget to differentiate the function inside here. Differentiate 4x plus 1 equal to 4. Okay. So then 4 divided by 2 equal to 2. Then it is 2 divided by 4x plus 1. Okay, next. Okay, now u equal to an x. So just imagine that this is u and this is v. Okay, so u equal to an x, so then u prime equal to 1 and v equal to natural log of x, then v prime equal to differentiate ln 1 over the x, and differentiate of x, it gives you 1 here. So then y prime or dy dx equal to u prime v plus uv prime. We call u prime and v 1 multiplied with natural log of x plus with uv prime, where x multiplied with 1 over x. Okay, so equal to natural log of x plus, okay, for this one here, 1. There you go. Okay, then now using this, we call, okay, this is the thing that we're going to use here. Then u we list down that this is u equal to natural log of x. So then u prime equal to differentiate ln or natural log 1 over x multiplied with differentiate of x equal to 1 here, and v equal to an x, then v prime equal to ex. So dy dx equal to u prime v, u prime equal to 1 over the x times v equal to ex minus u natural log of x, v prime equal to e to the power of x divided by v square, which is ex squared. Okay, so from here now, ex and ex, e to the power of x, it is 1 over x minus natural log of x, and divided by ex in bracket squared. Okay, so then we call divide e power of x with 1 over e to the power of x. So there's only e power of 1, e power of x left here. So 1 over x minus this. We are going to simplify the numerator here, 1 over x with ln x divided by 1. And it come out with 1 over x minus x natural log of x divided by x. And everything divided by ex. Okay. Come up with this one here, 1 over ex. So then 1 minus x natural log of x divided by x. Okay, for the term inside this bracket here, both with the denominators of x. So x equal now, and then multiply with an e to the power of x here. Okay. Okay, now differentiate e to the power of y equal to function here respect to the x. Okay, so for this one here now, let's recall, come up with natural log left and right here. Natural log of e to the power of y equal to natural log of everything here, x cubed, divided by square root of 1 plus x multiplied with x squared plus 1. Okay. So now, bring this y to the right side here, y natural log of e equal to, okay, so let's take a look at this one here, ln everything here. Please refresh our memories about the lesson in chapter 1. Log a divided by b. Okay, and this is log a minus log b. And log a multiplied with b equal to log a plus log b. Okay, so these things are this is the method that we're going to use to simplify this one here now. So you come out with natural log of x cubed minus, we divide here and also divide this one here, minus natural log of this one here, 1 plus x. Square root means to the power of half. Okay. One plus x to the power of half, and then minus with natural log of x squared plus 1. Okay, so take a look at this. Natural log of e, natural log, oh, not this one here. Okay, natural log of e, where natural log itself is a log to the base of e, where log e to the base of e equal to 1. Okay, now by looking at this one here, so we come up with conclusion that ln e equal to 1, then y equal to, okay, bring these 3, using log's rule, bring these 3 to the front here, 3 natural log of x, minus 1 over 2 natural log of 1 plus x, okay, and minus natural log of x squared plus 1. Okay, so y equal to 3 natural log of x minus half natural log of 1 plus x minus natural log x plus x squared plus 1. So this is the term or equation that we are going to derive or differentiate. So then dy dx equal to 3, differentiate ln x, come out with 1 over x. Okay, and then 1 over 2, differentiate natural log, 1 over 1 plus x. Okay, again, one plus x. Okay, and don't forget to differentiate 1 plus x, the function inside, differentiate 1 plus x, it gives you 1. Minus differentiate ln 1 over x squared plus 1, and don't forget to derive or differentiate x squared plus 1, and this gives you 2x. Okay, so now we come out with 3 over x minus, okay, 1 over 2, 1 plus x, minus 2x divided by x squared plus 1. That's it. Okay, now differentiate the following with respect to the x, natural log of this one here. Okay, the final answer given there is 2 divided by x minus 2. Okay, exercise. And also here, and this one here now. Okay, so copy all these answers and try this and one by one, see whether you can get or not. And if you can't solve this, so you bring these methods into your tutorial class. Okay, so given here, prove that second derivative of this minus n equal to 0. Okay, now differentiation of trigonometric functions are only true for angles which are measured in radians. So now let's take a look at this one by one. Differentiate sine x equal to cos x, differentiate cos equal to negative sine. So you are going to, okay, maybe you need to remember all of this. But then all this might be given to you during examination. Okay. And also this one here now. First, we will differentiate the the power of this trigonometric function sine x, sine to the power of n fx. So look at this one, n sine n minus 1 fx. Then differentiate sine fx. Differentiate sine, it gives you cos. Multiply with differentiate of fx equal to f prime x. Okay, let's take a look at these examples one by one. So now, y prime equal to 2 differentiate sine equal to cos x minus 3 differentiate cos equal to give you negative sine x. So 2 cos x negative times negative positive 3 sine x. Okay. And what about this one here now? Y prime equal to 4 differentiate tangent. Differentiate tangent, it gives you secant square x. Okay. And then minus 5 negative 5 and differentiate x power of negative 1 and come up with negative x to the power of negative 1 minus 1, you get negative 2 and differentiate 5 equal to 0. So 4 secant square x plus with negative times negative positive 5x power of negative 2, if is 5 over x squared. Okay. And now y equal to cosecant x squared. Y prime equal to differentiate cosecant. Differentiate cosecant negative cosecant x cotangent x. Okay, now negative cosecant x squared over 2 cotangent x squared over 2, and don't forget to differentiate the function inside, which is 1 over 2 differentiate, okay, x squared over 2. We can also write this as an 1 over 2 times x squared. So then differentiate half x squared, differentiate x squared 2x. Okay, so then here now 2 divided by 2. Okay, so then simplify, bring x in front here, negative x cosecant x squared over 2 cotangent x squared divided by 2. Okay, just to recall, look at this one here, differentiate cosecant, then the formula of this is negative cosecant x cotangent x. So in this case, differentiate cosecant fx, then differentiate cosecant negative cosecant cotangent, and differentiate the function inside. It gives you half 2x and divide by 2 here to bring x in front, negative x cosecant x squared over 2 cotangent x squared over 2. Okay, now for this one here now, y prime or dy dx. As I said that we are going to, okay, for this kind of question, so look at this one here now. Tangent power of n times fx. Okay, so we are going to derive the power of the trigo function here, where n tangent power of n minus 1 fx. Okay, this is the first priority. The first thing comes first here. And then tangent, differentiate tangent will be the second part, and then differentiate fx, the third part here. Now, for this question, meaning 4, okay, power of 4, this will be the first thing that we're going to look at. And then tangent, the second part, and 3x squared plus 1, the third part here. Okay, so I'm going to rewrite this. Okay, y prime. Okay, so for first, 4 tangent 4 minus 1 equal to 3x squared plus 1. Okay, multiplied with, we had derived the power of tangent 4 here, and then derive the tangent. Tangent, differentiate tangent, secant squared 3x plus 1. Okay, for tangent of 3x squared plus 1, derive this, derive tangent, secant squared, and differentiate 3x squared plus 1. Okay, differentiate 3x squared equal to 6x. Okay, 6x times 4, 24x, then tangent cube, 3x squared plus 1, then secant squared, secant squared 3x squared plus 1. Okay, so we differentiate the function one by one. Begin with the index of 4, and then the trigo function. Then next is the function inside the bracket, one by one. Okay, so for this one here now, so as an exercise here, differentiate, and the final answer is given there. Okay, so copy out the final answers and try by yourself. Okay, and also for the question of E, F, G, and H, and the final answers is all here. So try. Good luck. Okay, conclusion, derivative of exponential function. Okay, derive e power of x equal to ex and all here. Okay, so derivative of log function. and derivative of trigonometric function. So for this case, you just remember differentiate sine, then give you cos. Differentiate cos equal to negative sine. Differentiate tangent, secant squared. The differentiate cosecant x equal to negative. Don't forget we got negative here. Negative cosecant x cotangent x, and differentiate secant equal to secant x tangent x, and differentiate cotangent equal to negative cosecant square. Okay, so cosecant is 1 over sine x, secant is 1 over cos x, and cotangent is 1 over tangent x, or equal to cos x divided by sine x. Okay, so when we got three things that we need to consider here, first is the index or the power of the function, of the trigonometric function. So this will be the first priority. Then next, we differentiate the sine. Then we differentiate the function of fx. 1 by 1. So that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Until we meet again in the next series of my video, that's all again. Thank you.